Today we're going to talk about something called engineering mechanics on bridge analysis or beam analysis. I'm going to assume you guys already know everything about torque and moments and a little bit about angular momentum. If you guys don't know that, then of course check out the physics video on torque and moments. But yeah, I'm going to assume you already know all of this, and we're going to start doing truss analysis using torque. If you have a question on why we use torque instead of forces, because the thing is, there's a line right here. You see, if a force coming down like that, right? There's a perpendicular line, which means it will rotate the bridge. It wouldn't just move the bridge down, it will rotate it. So yeah, so we want to talk about bridges analysis and stuff using torques. Yeah. So if you have a bridge like this, let's say, and the force is coming down, force coming down directly in the center, directly below, force coming down from the center, and the distances between it is 125 meters and 125 meters. This bridge is a truss bridge, and there's two holds right here that helps that bridge. But yeah, we want to talk about so what are the forces coming back at the bridge. So we want to know the reaction forces. So essentially, when a bridge is loaded like that with 15 newtons in the middle, there's going to be a reaction force coming up from the right, and there's going to be a reaction force coming up from the left. And let's say reaction force coming up from the left equals that, and reaction force coming up from the right equals okay, right. And we want to find those forces out, and well, firstly, it is going to be 15 divided by 2, which is 7.5. But I'm going to show you guys why that's the case in math, in using torque. So let's get our direction out. Let's say that pointing down is negative, pointing up is positive, and if the moment is coming clockwise, then it's positive, and negative if it's anti-clockwise. Now let's write this equation down. So the sum of torque at this point, let's say it's point P, the sum of force in point P equals the torque 1. So there's a force coming down like that. Yep, so that's torque 1 plus torque 2, which is a force coming up like that. You see from the torque, the reaction torque. So torque 2 and torque 3 right there. So plus torque 1, torque 2, torque 3. So let's say torque 1 equals to 15 newtons times the 125 meters, which is going to be equals to 187.5 newton meters. And because this force is coming down, alright, therefore the newton is going to be negative, so this is going to be negative 1875 meters. Now torque 2 and then torque 3 is going to be equals to 0. So torque 2 is just this thing coming up right there, and because we know that's 0 meters, so 0 meters times some reaction value is going to be equals 0, and then torque 3 is going to be r reaction up, and then it's going to be this whole distance right here, and that whole distance is going to be 250 meters. And Essentially, we can write it as 250. Yep. So that's that. And we know that we want the truss to be in equilibrium, so the truss don't move. And how much force is going to take to balance out the 15 units from the top. So that means the torque is going to be equals to 0. So the sum of torque equals to 0, which means 0 equals to torque 1, which is 0, plus torque 2, which is torque 1, which is 100 negative 875, plus torque 2 is 0, plus torque 3 is R250, and then 0 is equals, and then 175 over here, and then R250, and then R250 we can cancel that out, and then we get 7.5 newtons, 7.5 newtons for RR. So that's the reaction force from the right, that's 7.5. Now what is the reaction force from the left? Well, we're going to say sum of the forces in the y direction is going to be equals to one force coming down, like that. So one force coming down, which is negative 15 newtons, plus 7.5 newtons, the R force we already said, and the RL plus RL, the reaction force from the left, is going to be equals to 0. Everything is going to be equals to 0 because it balances out, and which means that negative 15 plus 7.5 is negative 7.5. 0 equals negative 7.5 plus RL, and therefore 7.5 equals RL. Sorry if you can't see, 7.5 newtons equals RL. So therefore, when a load coming down like that, there's going to be a reaction force 7.5 newtons from the right and 7.5 newtons from the left.